Okay, so I'm going to do this question here, which is 4C. So it's find the coordinates of any points of inflection of e to the power of x times x squared plus x plus 1. So I'm going to do that one. There's the function. So first of all, we need to find f dash of x. So I've got u equals e to the power of x. I've got v equals x squared plus x plus 1. I've got u dash equals e to the power of x. V dash equals 2x plus 1. So I'm going to put that into the product rule. So I've got that times that, plus that times that. I'm going to factorise out the e to the power of x to simplify this. Simplify what's in the bracket. Okay, I'm going to differentiate again, because to find the point of inflection I need to identify where the second derivative is 0, so I need to differentiate again. So I'm going to use the same method. Put that into the product rule again. I'll factorise out the e to the power of x, but can we see those are just going to be added together, so I'll do that in one step. So that's x squared, I've got 5x plus 5. Okay, so we now need to establish where f dash dash of x equals 0. So if I say either that must be true, that must be equal to 0, or that must be equal to 0. So e to the power of x equals 0 has no solutions. We know that because e to the power of x looks like that, has an asymptote at the x-axis. There are never any values where that becomes 0. X squared plus 5x plus 5 equals 0. So we're going to use our calculator to solve that. So I'm going to put 155 in, and I get x equals minus 5 plus root 5 over 2, which is minus 1.381, or minus 5 minus root 5 over 2, which is minus 3.618. Okay, so that gives us the values where d2y by dx squared is 0, second derivative is 0, f dash dash of x is 0, all the same words are the same thing. We just need to establish that on just either side, that at that point there is a change in value of f dash dash of x. So I'm going to say that at minus 1.380 f dash dash of x equals, and I'm going to work that out. I'm going to put that into my calculator. So there's my function for f dash dash of x. So I'm going to say, I'm going to calculate e to the power of minus 1.380. Can you see I've just gone slightly down, just a tiny bit down from the x value that we're given. I'm going to minus 1.380. Oops, sorry. I need to square that. Squared plus 5 times minus 1.380 plus 5, and that gives me 1.1 times 10 to the power of minus 3. At 1.382, I'm going to do the same thing, and I'm just going to establish what I'm hoping for here is that there is going to be a negative value for the second derivative, which is going to establish that there is a point of inflection. So wherever I put in 381, I'm going to put in 382. So that's just slightly below the x value. And there we go. I have minus 1.9 times 10 to the power of minus 5, I think that is. Minus 5. So, change of sign of f dash dash of x, therefore there is a point of inflection at minus 5 plus 5 over 2, or x equals that. Now then you would need to do it with the other one, just to make sure that there's a change of sign on the f dash dash of x, just on either side of that. And that's how we go about it. Just bear in mind that it's not just okay to find the point where the second derivative is equal to 0. We need to do a little bit more, because there are curves where the second derivative is 0, but it is not a point of inflection. And if you want to consider where that might be the case, think about the curve y equals x to the power of 4, and that will give you some indication of why we need to do that. Okay, hope that was helpful.